So hello everyone, welcome back to our Python programming fundamentals course. I hope all of you are doing well and have revised concepts we have discussed in the previous lecture. So today's section, we are going to take our first real step into writing Python programs. We'll learn about values, data types, variables, input and output, expressions, operators, and many other fundamental concepts that every Python programmer must understand. So let's start. So before we move forward, let's quickly revise what we have learned in the previous lecture. In our first class, we understood what programming is. We learned that programming is the process of giving instructions to a computer to solve a program. Just like we give step-by-step instructions to a person or to complete a task, we also give step-by-step instructions to a computer using programming languages. After this, we discussed about programming process. We saw every program starts with a problem. Then we prepared an algorithm represented using a flowchart or pseudocode, write the actual program, execute it on the computer, and obtain the output. This systematic approach helps programmers solve problems easily. Next, we understood what an algorithm is. An algorithm is simply a sequence of logical steps to solve a problem. We also learned that good algorithm should be clear, correct, simple, efficient, and finite. Then we studied flowcharts, where we represent algorithms using graphical symbols like start, process, descent, input output symbols. Flowchart make the program logic easier to understand for us. After that, we learned about pseudocode. Unlike flowcharts, pseudocode uses simple English mixed with programming style keywords to describe the solution. It's not an actual programming language, but serves as the bridge between algorithms and real code. Then we discussed programming languages. Since computer understand only program machine language, programmers use language such as C, Python, C++, and Java to communicate with computers. We also learned about compilers and interpreters. A compiler translates the entire program before execution, whereas an interpreter translates and executes one line at a time. Since Python is an interpreted language, it is easier to learn and debug, making it a easier to excellent choice for beginners. Finally, we discussed why Python is so popular. Since it's because its simple syntax, readability, portability, and wide range of applications make it one of the most widely used programming languages today. After at the end of the lecture, we wrote our very first program, which is this single program introduces us to the print function and mark the beginning of our programming journey. So before we continue, let me ask you a few questions. Can you tell me what is an algorithm? Very good. Now another question. Python use a compiler or interpreter? Yes, we use interpreter. So Python uses an interpreter which executes programmers line by line. One final question. Which function did we use in our first Python program? Exactly, the print function. Excellent. This makes everyone remembers the previous lecture well. So now let's see what we are going to learn today. In today's lecture is much more practical than the previous one. Today we will understand what a value is, different data types available in Python, how to create and use variables, rules for naming variables, Python keywords, taking input from the user and displaying output, formatting output using F strings, escape sequence, Python statements and expressions, different operator and operator precedence, basic string operations. Finally, we will learn about commands which help us write clean and understandable programs. By the end of today's lecture, you will be able to write small Python programs on your own using variables, input, output, and operators. Everything that a computer works with numbers, text, or even true or false is stored in some form of data. Before we learn about variables and programming, first we need to understand the smallest unit of data in Python. This brings us to our first topic, what is value. So now let's begin with our first topic called values. The word value may sound very simple because we use it in our everyday life. In Python programming, it has specific meaning like a value is the basic piece of data that a program works with. In simple words, a value is any information that can be stored, processed, or displayed by a computer. So let's understand with simple example. Imagine you have a notebook. Inside a notebook, you can write your marks, your name, your age, whether you are passed or failed. Each of these is a piece of information. Similarly, in a computer program, every piece of information is called a value. Without values, a program has nothing to work with. So let's look at the example given in the PPT, like 10, 3.14, Python, true. These are all values, but they are different kinds of values. Let's understand each one of them. So integer value, the first value is 10. 10, this is a whole number. It has no decimal point. Numbers like 5, 100, or minus 25, 0, all are integer values. Floating point value. The second value is 3.14. Notice the decimal point. And any number containing a decimal is called a floating point value or simply a float. Examples include 99.5, 75.25, 0.0001. These are all useful when a precision is required. For example, where and all precisions will be required, like the areas like height, weight, temperature, and speed. Most of these measurements can contain decimal values. The third example is Python. This is called a string. A string remembers text. Whenever we write words, names, or sentences, we place them inside a quotation marks. Example include India, hello, as my name is Bharat, we can have the string with Bharat. Python programming. If the quotation marks are missing, the Python will think it is something else, such as a variable, and may generate an error. The last example is Boolean, like true or false. This is called a Boolean value. A Boolean has only two possible values, true, false. These are mainly used when making decisions. For an example, is the student present? Yes or no? Is the password is correct? True or false? Is the number greater than 100? Again, the answer will be either true or false. We will learn much more about Boolean values when we study conditions later in the course. In real life examples, let's connect these values with our day-to-day life. Suppose we are storing information about a student. The student age is 19. This is an integer. If the student CGPA is 8.75, this is a float. If the student's name is Bharat, it's a string. Finally, has the student paid the examination fee? True. This is a Boolean value. So different types of information require different kinds of values. So why are values important? Now, you might ask, why are values so important? Think about any applications you use. Instagram uses username, WhatsApp uses messages, banking applications store account balances, Google Maps store locations, game stores about scores. Every application works with data, and these data is nothing but values. Without values, programmers cannot perform any useful work. Let's do a small activity. I will say a value. You have to tell me what type is it. Ready? 100. It's an integer. Next, 89.6. It's a float. Python. Exactly. It's a string. Finally, false. it's a boolean value. So before we are moving ahead, remember these points. A value is the basic point piece of data in a program. A values represent numbers, text, or logical informations. Examples from today's slides include 10, 3.14, Python, true. These are all integer, float, string, boolean respectively. So now we have know that Python work, the programs work with different kinds of value. But how does Python know whether a value is an integer, a string, or a boolean? To identify these kind of value we are working with, Python provides a built-in function called type. Now let's understand the type function next. In the previous topic, we learned that Python works with different kinds of values such as integers, floating point numbers, strings, and boolean values. But here is an important question. Suppose someone gives you the value like 25. How do you know whether it's an integer? Or someone gives you a string called Python. How do you know it's a string? Python provides a built-in function called type to answer exactly these questions. So what exactly is the type function? The type function is used to identify data type of a value or a variable during program execution. In simple words, it tells us what kind of data Python is actually working with. Think of it like checking someone's identity card. Just as an identity card tells you who a person is, the type function tells you what kind of value the Python dealing with. The syntax is very simple. Type within parentheses, we will be having the value. Here, instead of value, we can write a number, a string, a boolean value, or even a variable. Python will immediately return the data type. So let's try with an example used in interpreter. I've opened the Python interpreter. There I am giving print type 10. So what does Python return? It returns class int. This tells us that 10 belongs to the integer data type. The second one is, one minute, print type of 3.14. And if I hit enter, it says class float. Since 3.14 contains a decimal point, Python identifies it as a float. Now the third example, print type Python. If I hit enter, it says class string. The result shows string, which stands for string. That means str. Remember, whenever text is written inside a quotation mark, Python treats it as a string. Let's check with a boolean value. Print type of true. Class bool. So Python tells us the true belongs to the boolean data type. So now we will be using with some variables. The type function isn't limited to values. Can also identify the type of variable. For an example, if I have age equal to 19 and then print type of age, then if I hit enter, it says class int. Similarly, name equal to Bharat and print type of name, and it says class str. This shows us the type works with both values and variables. So you may wonder why type is useful. Why do programmers use this function? Imagine you have written a large Python program. Somewhere in the program, a value is producing an unexpected result. Without of guessing whether it's an integer, string, float, you can simply use type of to check it. This helps programmers understand their data and also make debugging much easier. That's exactly why type function is commonly used while learning Python and during program developments. One interesting point mentioned in our PPT is that the same type function can also be used with three arguments to dynamically create classes. Since today's lecture is focused on fundamentals, we won't study that advanced usage now. For now, remember the simple use. Type function help us identify the data type of a value or a variable. Let's try a quick exercise. Tell me the output of these statements, like let me have it. Print of type 100. Exactly, it will return class integer. Now let's consider print type of hello. It returns class string. Now print type false. It returns class bool. So before we move ahead, remember these important points. Type function is a built-in Python function which identifies the data type of a value or a variable. It is commonly used during programming and debugging. This works with integers, floats, strings, booleans, and also variables. Now we know how to identify the type of value, but what are the different types of data that Python supports? Let's move on to the next topic, data types. In the previous topic, we learned that Python works with different kinds of values. Some values are whole numbers, some contain decimal points, some are text, some are either true or false. Now the question is, does Python recognize all these different values? How does it do? The answer is through data types. A data type specifies the value type stored in the memory. In simple words, a data type tells us Python what kind of information is being stored so that the the Python knows how to store it, process it, and perform operations on it. So actually, why do we need data types? Let's understand with a real example. Imagine you are organizing items in your hostel room. You don't keep your clothes, books, toiletries, and food all in the same place. Instead, you separate them. Clothes go into the wardrobe, books go on the shelf, toiletries stay in the bathroom, food kept on the containers. Why? Because each type of item has its own purpose and storage method. Similarly, Python also organizes different kinds of data using data types. This makes programs much more efficient and prevents confusions. So here are some common data types in Python. So based on this PPT, Python provides several commonly used data types like integer, float, string, boolean, list, tuple, dictionary, set. Let's understand each one briefly. Integer. An integer is a whole number. It does not contain any decimal point. The examples include 10, -25, 0, 500. These integers are used whenever we work with whole numbers. For an example, student roll numbers, number of books, number of employees, age in years. These never contain decimals, so that's why we have integers. Float. A float represents numbers that contain a decimal point. Examples include 3.14, 99.6, 75.25, 0.5. The float values are commonly used for temperature, height, weight, CGPA, speed. Whenever precision is required, Python uses the float data type. The third one, string. String are written inside a code single quotes, double quotes, or triple quotes. So examples include Python, hello, my college. So whenever we store numbers, addresses, messages, or sentences, we use strings. For an example, name equal to Bharat, city equal to India. Boolean. A Boolean represents only two values like true or false. It is used mainly when making decisions. Suppose we ask, is the truth and present? The answer is either true or false. Similarly, is the password correct? Again, the answer is Boolean. We will use Boolean values extensively when we study conditions later. A list is used to store multiple items in a single variable. The lists are ordered, mutable, they can be changed after creation. Examples like marks equal to 85, 90, 78, 92. These are in sequence and in an ordered way. Instead of creating four separate variables, you can store all the marks in one list. Lists are one of the most frequent used data types in Python. Tuple. Tuple is very similar to list. The main difference is the tuple are immutable. That remains one once a tuple is created, its elements are cannot be modified. For an example, there are if I have a variable days, there will be like 7 elements starting from Monday till Saturday, and these cannot be changed. This is a sample example for where we'll be using tuples. Tuples are useful when the data should be remain fixed throughout the program. Examples like days of week, months of year, coordinates on a map. The seventh one, dictionary. A dictionary stores the data in key value pairs. Think of a real dictionary. You search for the word and it gives you a meaning. Similarly, every key is associated with a value. If here name is the key and Bharat is the value. So dictionary are useful whenever the information has labels. Eighth one, set. A set stores unique elements. It doesn't allow duplicate values. Examples like numbers 1, 2, 3, 4. And if you try the same value multiple times, Python stores it only once. Sets are commonly used when duplicate data should be removed automatically. So here are the PPT slides in which I have discussed these topics well. So, and here the example, let's try it. So the first output will be integer, the second one will be float, the third one will be complex. So sequence of data types. String are used to store text data. A string is represented using string class and can be created using single, double, or triple quotes. Here, one such example is welcome to the program. Print yes. The first statement makes the program display welcome to the program. Print type of x prints the actual type of the variable which is string str. While accessing the index, we'll have print yes square bracket 1, which prints the second element of the string, which is e, and yes minus 1 prints the last element of the program, which is m. So list, I have also discussed this thing. Tuple also done, and for an here is the example for tuple. Note, a tuple is a single element must include a trailing comma. Otherwise, the Python reaches a normal value instead of a tuple. So here I have given accurately. If I want to have a single only one element with 1, after that I have to give comma. Otherwise, Python won't consider it as a tuple. So if I have this kind of statement and if I have print type 1, it says class tuple. The another there is one another tuple like which is given for how we can access tuples. And the fourth one is Boolean. We have discussed it well. Boolean has two data types like true or bad, false. So these are mostly used when conditions and comparisons are represented with Boolean class. Sets are unordered, mutable collections to store unique elements. So these cannot be accessed with indexes as this is an unordered type. So elements are usually accessed with iterating through the set using a loop. So here is an example clearly given where the S1 is a set of alphabets like A, B, C, D, but it has duplicates within it. But while I print it, it prints only the unique value, but not in an ordered way. Even though I have given A as the first value, while printing, it displays B as the first value, first element inside the string list. I mean set. So for accessing and set, we have to have S2, I mean a separate set, and then we'll be using for loop for traversing through each of the set. So dictionary data type is a key value type, which is very well understood by you guys. So far we have learned about different types of data, but if we want to use these values later in our program, we need a way to store them. That's where variables come in. Let's learn how variables help us store and reuse data throughout the program. We know that different data types. The next question is, suppose I want to store a student's name or your CGPA, maybe your mobile number. Where will the Python keep these informations? The answer is variables. Variables are one of the most important concepts in the programming. Without variables, writing programs becomes almost impossible. So what exactly is a variable? So according to the PPT, variables are used to store data that can be referenced and manipulated during program execution. A variable is essentially a name that is assigned to one value. Let's understand this in a simple language. A Python, in Python, a variable is simply a named storage location. Instead of remembering the exact value, we remember its name. So imagine your hostel room has several containers. Instead of writing contents every time, you just put labels on them. One container is labeled books, the another labeled clothes, the another labeled snacks. So whenever you want books, you simply look on the for the container named books. You don't have to search the entire room. Variables works in exactly the same way. The label is the variable name and the contents are the value. Suppose your age is 19. Instead of writing 19 everywhere, we write age equal to 19. Here, age is the variable, equal to is the assignment operator, 19 is the value. So now, whenever Python sees age, it automatically understands that it represents 19. Let's store student's name. Name equal to Bharat. Here, variable is name and value given is Bharat. Now, we can use name everywhere in the program. For an example, print name. The output will be Bharat. So let's try it practically. Like if I have name equal to Bharat, and if I print name, it prints Bharat. Notice something interesting. We didn't write Bharat inside print function. We only wrote the variable name. Python automatically retrieves the stored value. Variables can store any data type. They can store almost every data type. For an example, age equal to 19, CGPA equal to 9.59, name equal to Bharat, past equal to true. So these, let's identify each of the data type. Age is an integer, CGPA is a float, name is a string, and past is a boolean. So variables can hold any kind of value. So one specific feature in the Python program, like in the PPT mentioned, is unlike Java and many other programming languages, Python variables do not require to declare the data type explicitly. Python automatically determines the type based on the assigned value. For an example, age 19. Python automatically understood that age is an integer. So, and there are the examples which I've given exactly before. There we didn't even declare the variables and its data type. So this feature is called dynamic typing. It makes Python much easier to learn than languages where you must declare the data type before creating a variable. Now let's understand what happens internally. Consider marks equal to 95. What exactly happened in three steps? Python creates the value 95, stores that value in memory. It associates the name marks with that memory location. So whenever you use marks, Python retrieves the stored value, reassigning variables. Variables can be anything. Like for an example, score 50, score 90, score 90. Here, initially, score stores 50. Later, we assign 75. Now the world value is replaced. So when we print, let me have an example here. First, I'm having score equal to 50. Then I'm changing score to 90. So when I print score, Python prints 90. So the latest value is always used. So now variables become more powerful when we perform calculations. So let's consider a equal to 10 and b equal to 20. So let's have a variable sum a plus b. So if I print sum, it gives 30 as an output. Notice that we didn't directly add numbers. We added variables. This makes programs flexible and reusable. Let's do a quick exercise. Suppose I write city equal to Chennai. What exactly is the variable name? It's city. And what's the stored value? It's Chennai. Let's try another one. Temp equal to 32.5. So what data type is stored? Correct. Float. So before we are moving ahead, remember these important points. A variable stores data. A variable is simply a name assigned to a value. A variables make programs easier to read and reuse. Python automatically detects the data type based on the assigned value. Unlike Java, Python does not require explicit type declaration. Now we know what variables are and how they are stored. But can we give any name to variables? Can we name a variable one, 123 name or a class? To answer these questions, let's move to the next topic, variable naming rules. Now the question that we already know data types of data, different types of data. The real question is, suppose if I want to store a student's name or a CGPA or your mobile number, where will Python keep this information? The answer is variables. Variables are one of the most important concepts in programming. Without variables, writing programs will be almost impossible. So this is the thing we already saw about variables. Let's see about the naming conventions. Now we already know about variables and how they are stored values. But here is an important question. Can we give any name to a variable? Can we write something like 123 name equal to Bharat, class equal to 10? Will Python accept this? The answer is no. Just like every country has traffic routes, Python also has rules for naming. Though if we don't follow these rules, Python will generate an error. Let's understand them one by one. Rule number one, variable names must start with a letter or underscore. Examples like name equal to Bharat, age equal to 19, underscore marks equal to 95. All these are valid, but this one is invalid. One name equal to Python. Why? Because it starts with a number. Python does not allow variable names to begin with digits. Rule number two, variable names cannot start with numbers. You can use numbers after a first character. For an example, this one is valid, like student1 equal to Rahul, marks 2025 is 95. But this one is invalid, 2025 marks equal to 95. Always remember, numbers are allowed but not at the beginning. Rule number 3, only letters, numbers and underscores are allowed. Python allows only three kinds of characters, like letters, numbers, underscores. Special symbols are not allowed. The special symbols include hashtag, at the rate, percentage, dollar, and extra simple, multiplication. These are variable names, but if we have inside a variable name, it results in an error. For example, the name hashtag equal to 50. So here it results in an error. Python will report these as syntax errors. So the valid version should be student underscore name, total underscore marks, student1. Variable names are case sensitive. So if I have name equal to Bharat, name equal to Python, and name equal to programming, all these are same but different because Python treats uppercase and lowercase letters different. These are three different variables and they are completely separate. So always be careful with capitalization. Rule number 5. Do not use Python keywords. Some words already have special meanings in Python. For an example, words like if, for, while, class, return. These are reserved keywords. They cannot be used as variable names. For an example, if I have class equal to 10, this is invalid because class is a keyword. We will learn more about keywords in the next topic. Rule number 6. Use meaningful names. This isn't a syntax rule, but it's good for programming practice. Suppose you are storing a student's age. Which age is better? X equal to 19 or age equal to 19? Obviously, it will be age. Is something better? Similarly, instead of A equal to 55,000, write salary equal to 55,000. Meaningful names make programs easy to read and maintain. So here is a comparison between good versus bad variable names. Good variable names include student name, total marks, mobile underscore number, CGPA is underscore present. These names clearly describe the store data. The banned ones include A, X1, ABC, temp 1, 2, 3, 4, 5. Someone reading the program won't be immediately understanding the purpose. So let's check whether these variable names are invalid or not. Student underscore name. Is it valid? Yes, it's valid. What if 2 equal to marks? It's invalid as it starts with a number. Total marks. Valid. Student hyphen name. Invalid as hyphens are not allowed. Class. Invalid. It's a Python keyword. Excellent. So when we are writing Python programs, always try to use meaningful variable names, keep names short but descriptive, follow Python naming conventions, avoid unnecessary abbreviations, use lowercase letters with underscores for multiple words. So here are some points to remember. Before moving ahead, remember these rules. Variable names must start with a letter or underscore. They cannot start with a number. Only letters, digits, and underscores are allowed. Variable names are case sensitive. Keywords cannot be used as variable names. Always choose meaningful names. These simple rules will help you avoid many common programming mistakes. While discussing variable names, we learn some words like if, for, and class cannot be used because they have a special meaning in Python. These results words are called keywords. Let's understand Python keywords in the next one. Now, let's move to the next topic, Python keywords. So, while discussing variable naming rules, I specifically mentioned that some words cannot be used as variable names because they already have special meaning in Python. These specific words are keywords. So, according to the PPT, these keywords are special reserved keywords that are part of language itself. They define the rules and structure of Python programs. This means you cannot use them as names for keywords, functions, class, or other identifiers. So what are keywords? Now let's understand with a simple example. Suppose you are playing cricket. Words like out, four, six already have specific meanings. You cannot suddenly decide that out means run. Everyone follows the same rules. Similarly, Python reserved words whose meaning are already defined. We cannot change them. Specific examples of keywords include if, else, for, while, class, def, return, true, false, none, input. The PPT contains the complete list of Python keywords. Why can't we use keywords as variable names? Let's see an example actual. If I have a variable name class, which is a keyword equal to Python, and will this work? Actually, no. Python immediately will show a syntax error. Why? Because class is already a keyword used to clear classes in Python. Now, similarly, if equal to 100, will this show any error? Exactly. This will also show an error as word if is already reserved for decision making statements. Valid alternative names. Instead of writing class equal to Python, we can write class underscore name equal to Python. This won't create any errors. So if instead of if equal to 20, we can have if underscore condition equal to 20. So these are perfectly valid because they are not part of keywords. How can we check Python which one is a Python keyword? So for this we have to import a library called keyword, and within that have print keyword dot keyword list. And if I hit enter, this will execute the program and it displays the complete list of the reserved keywords available in the current ones. This demonstration matches with the idea of PPT listing keywords. So let's identify whether these keywords are not. For an example, for, correct, it's a keyword. Student underscore name, exactly, it's not a keyword. While, it's a keyword. CGPA, it's not a keyword. Variable name and not a keyword. Okay, so points to remember. Before moving ahead, remember these important points. Keywords are reserved words in Python. They already have predefined meanings. They cannot be used as variable names, functions, or class names. Python provides the keyword module to display the list of keywords. So far, all the values in our programs are written directly by us. But if we want the user to enter their own name, age, or marks, for that, Python provides input-output functions. Let's learn about input and print because they are the among most frequent used functions in Python programming. So now let's move to the one of the most important topics in Python programming, which is input and output. Until now, all the variables, all the values in programs are written by the programmer. For example, print hello world or age equal to 19. Here, the values are fixed. But imagine you are creating an ATM application. Will every customer have a same PIN? That's exactly no. Or if you are creating a student management system, will every student have the same name? No. So even hard coding variables, values, we should allow user to hint their own data. That's exactly why Python provides input and output function. Now let's begin with output. Output means displaying information to the user. In Python, we use print function to display their own data on the screen. Think of it like suppose you are using an ATM. After withdrawing money, the ATM displays transaction successful. This is a message of an output. Similarly, whenever Python program displays a text, numbers or results on a screen, it uses print function. So what exactly is a print function? So the syntax is very simple, like print hello. That's it. So the output will be hello. The text inside the quotation marks is called string return. When Python executes this statement, it simply displays the text on the screen, printing different types of values. The print function is not limited to the text. It also can do print 100. The output will be 100. Similarly, print 3.14. The output will be 3.14. It can also display Boolean values like print true. So, print function works with different kinds of data. Now, let's see about printing with variables. If I have variable called name and Bharat, if I have name or Bharat, and then if I have print name Bharat, it prints Bharat. Notice something important. We wrote print name, not print Bharat. Print quoted name. So if I write print quoted name, it does just print name. Without quotation marks, Python prints the values stored inside the variable. And if we use quotation marks, Python actually prints the actual word name. So if this is a common mistakes done by users, many beginners. Now let's learn about input. Input function, the exact syntax will be input message. So what exactly is an input message? 1 minute. So give me a minute. Yep. So input message. This message inside quotation marks is called the prompt. It tells the user what exactly the information to enter. So let's write a simple program where we'll be having name equal to enter your name, and if I print name, what will I do? Suppose the user enters Bharat, that's the name, and the output will be exactly was which I given print name. So here it is what happens step by step. So the Python displays the message, enter your name. The user types the name. The enter value is stored inside the variable called name. The print function displays the stored value. Suppose if I want to get the student's age equal to input enter your age. The next line will be print age. If I save it and run, it's ask enter your age. I give 19 as the input. The displayed output will be 19. It's very simple, right? So there is one important topic important point about input. Just remember this. By default, Python input function returns user input in the form of string. So if the user enters 25, the Python treats as 25. So here, if I give type of age and then hit enter, it says class string. So this is exactly what is happening inside Python. We will learn later how to convert it to an integer using function like int of x. We will consider it later, okay? We will do it later stage. For today's lecture, just remember this important point, okay? Now, let's do one small activity. All open your any interpreter or any script file where it's supposed Python. Open like VS Code or ideally it's whichever which you're uncomfortable. Write name equal to input, enter your name, print welcome, then print name. Save it and run it. It asks enter your name, give your name. Did everyone get the output? Excellent. Now change the message from welcome to Python programming. Save it and run it again. Give me a minute. Here, I'll be giving my name here again. It says welcome to Python programming Bharat. So this is how interactive programs are created. Before we move to the next topic, always remember these points. Point number one, print is used to display output. Input is used to receive input from the user. Message inside input is called prompt. By default, input always returns a string. Input and output are the foundation of interactive Python programs. So far, we have used print to display simple messages. But what if we want to display variables and text together in a clean and professional way? Python provides a powerful feature called print formatting, especially f-strings. Let's learn f-strings, print formatting next. Now, let's move to our next topic, print formatting. So far, we use print function to display simple text or variables. For an example, name equal to Bharat, print name, or age equal to 19, print age. These examples are simple, but what if we want to display complete sentence like my name is Bharat and I am 19 years old? How can we combine these texts and variables on a neat professional way? Python provides an useful feature called formatted strings or simply f-strings. So what exactly is an f-string? So according to the PPT, f-strings allow you to format selected paths of string to a specific string as an f-string. Simply put an f in front of the string returner. In simple words, an f-string allows us to insert the values of variables directly into the string. Let's make the code cleaner, easier to make, and easier to write. Syntax is f of text and then curly braces variable and then close the braces and then this one. Notice that f before the quotation mark. Okay. So that single letter tells Python this string contains variables that need to be replaced with the values. Now let's open the compiler and type name equal to your name and then print f my name is the respective name. Okay, if I save it, sorry, if I hit enter, what happens? Python looked inside the curly braces and found the variable name. It replaced the curly braces this spot and with the actual value stored inside the variable, and we get the output. Very simple, right? Let's use two variables. I mean, let's use age equal to 19. Print f of my name is curly braces name and I am years old. If I hit enter, it says my name is Bharat and I am 19 years old. Now the sentence look more natural and professional. Placeholders. The PPT actually mentions that curly braces are called placeholders. A placeholder tells Python insert the value of the variable here. For an example, city, Delhi, print F I study in this city. So the placeholder city is automatically replaced with the value stored in the variable. Placeholders can also perform calculations like a equal to 50, a equal to 10 and b equal to 20. Print the sum is a plus b. The sum is 30. Notice something interesting, we didn't create another variable. We just perform the addition inside the placeholder. This makes the code shorter and more readable. Formatting the numbers. The PPT also introduces modifiers. A modifier is added a column inside a placeholder. Example is like point to f. So display the floating number with true decimal point. If I have a variable called CGPA with 9.58764 and if I want to print only two decimal places, I will be using my CGPA is curly braces which is a placeholder CGPA dot colon point to f. This one is called modifier and it prints my CGPA is 9.59. Python automatically rounds the value to two decimal places. This is very useful in displaying marks, prices, percentages, or even measurements. So why we use f-strings? You may ask, why should we use f-strings instead of normal print? There are several advantages like it's easy to read, they reduce amount of code, they automatically insert variable values, they support calculation and formatting, they make output look more professional. That's why f-strings are widely used in Python programs. Okay, now before we are moving ahead, remember these important points. An f-string starts with a letter F. Curly braces are used as placeholders. A placeholder can contain variables, expressions, and operations. Modifiers like point to F help format numbers with a specific number of decimal places. So far, we have learned how to display text neatly using f-strings. But sometimes we want to display text in multiple lines, insert tabs, include quotation marks, insert string, or write up file paths. That's for those situations, Python provides an escape sequences. So let's learn about escape sequence in the next one. Mm, Now let's move to the next topic called escape sequences. So until now we have printed simple text like print hello, but sometimes we also want to display text in a special format. For an example, we want the output in multiple lines. We want to insert a tab space. We want to print quotation marks inside a string. We want to display a Windows file path. How can we actually do this? For these situations, Python provides escape sequences. So what exactly is an escape sequence? According to the PPT, escape characters are used when we need to include special characters in a string that are otherwise difficult or illegal to type directly. They begin with a black slash. In simple words, escape sequence is a combination of characters that starts with the backslash. So when Python sees a black slash, it understands that the next character has a meaning. So why do we need escape sequence? Imagine you are writing an invitation. Instead of writing everything on one line, you naturally write name, address, phone number in different lines. Similarly, while displaying output, we often need different lines for proper spacing. Escape sequence help us the format output neatly. So these are some example for escape sequences. So they are new line, which moves the cursor to the next line, tab, which adds the horizontal table, black slash, which inserts literal black slash, string quote, which inserts the string quote inside a single quoted string, double quote inserts double quote inside a single quote double quoted string, carriage return, moves cursor to the beginning of line, space, moves cursor one space back, effectively deleting the last character, form speed, Prover moves the cursor to the next page. Vertical tab moves the cursor vertically. Hexadecimal represents the character using hexadecimal value h. So, so far we have written individual lines of Python codes, but every line is written actually a statement. So let's understand what statements are in Python and why the indentation is so important. Here, the statement is simply an instruction that Python executes. Examples include assignment statements, conditional statements, loop statements, x equal to 10, and printx. Both lines are Python statements. According to the PPT, Python has different kinds of statements such as assignment, conditional, and looping statements. Indentation. One unique feature of Python is called indentation. Unlike C, C++, Java, Python does not use curly braces. Instead, it it uses spaces or tabs to define block of code. Example like age equal to 18. If age is greater than or equal to 18, print eligible. Notice the four spaces before print. Without indentation, Python gives an indentation error. Remember, use four spaces. Keep indentation consistent. Don't mix tabs or spaces. The next one is comments. Comments are the notes written for programmers. Python ignores comment during the execution. For an example, print hello. Comments help. Here this is a comment. This is a single line comment which helps explain code, makes programs easy to understand, and are useful for future reference. PPT also mentions doc scripts, which are used to document modules, classes, and functions. We will study them in detail later. So, what is an expression? An expression is a combination of operands and operators that produce a value, like 5 plus 3 results in 8. Examples like arithmetic 1, 10 plus 5, relational one 10 greater than 5, logical one true or false, and bitwise. Bitwise are bit level operations. So these categories are introduced in the PPT. So if we have some operations, if we have some operator, when an expression, the expression contains a multiple operators, Python follows an operator precedence. So making it decide which operator is executed first. For an example, print 2 plus 3 multiplied by 4. The output will be 14 because multiplication has higher precedence than addition. So these are some list of operator precedence. It starts with parenthesis, then exponential, and after that unary plus, then multiply, divide or modulo, addition, subtraction, then shift operators, bitwise AND, bitwise OR, and bitwise OR, comparison operators, equality operators, assignment operators, and identity and membership operators, and finally logical operators. So this PPT introduces three basic string operations like concatenation, repetition, and indexing. For an example, if I have name equal to Bharat, and if I want to print hello plus name, Python prints hello Bharat. So in summary, today we have learned values, data types, variables, variable naming rules, keywords, input and output, print formatting, escape sequences, statements, indentation, comments, expressions, and operator precedence. From today's lecture onward, we have to you have the foundation to start simple Python programs. In the next lecture, we will build the basics with more programming concepts and hands-on coding. Thank you everyone. See you in the next class.